Hello everyone, welcome back. Today we will be solving one LeetCode question. Search in rotated sorted array. There is an integer array nums sorted in ascending order with a distinct value. Prior to being passed to your function, num is possibly rotated at an unknown pivot index. For example, here the array 0, 1, 2, 3, 4, 5, 6, 7 might be rotated at the pivot index 3, and then it becomes the array with the value 4, 5, 6, 7, 0, 1, 2. Given the array num, after possible rotation and an integer target, return the index of the target. If it is in the number, otherwise just return back -1. And the most important part is you have to write an algorithm with the time complexity of O of log n. Here we have the array nums with the element 4, 5, 6, 7, 0, 1, 2. Obviously, it was rotated and the target is 0. So we want to find the number 0 here in this array. 0 is in this array and it is at the index 4. 0, 1, 2, 3, 4. Here's another example. This is the array and the target is 3. However, 3 is not in this array, so we just return back -1. How do we solve this problem? The goal here is to search for the target number in this array. And of course, we can simply loop from the first element until the last element. And while looping, we can keep checking if the target is in the array or not. And if it is in there, we can just return back the index. However, if we loop from the first element until the last element, the time complexity gonna be O of n because we have to loop through the entire array. And the goal here is to get the time complexity at O of log n. And to get O of log n, we can use binary search. However, for the binary search, it will only work at a sorted array. And for our array here, it is sorted, but it is also rotated. As a result, we will use the binary search with some modification. Let's start with the normal implementation for the binary search first. And after that, we can modify it along the way. For the binary search, we will initialize the left pointer I with the index 0, the first index, and j with the last index of the array. So num.length -1. And here is going to be I, and the last element here going to be j. And we have to loop from I until j because we want to check the element between these two indexes. And while looping, we want to get the middle index. So I will just put k here as the middle index. And the middle index we will get from I plus j divided by 2. And we also have to do floor because we don't care about decimal. This is also the pivot point. And while looping, we want to check if the pivot point is equal to the target number or not. If it is equal, we can simply return back the index. Here, if num k equal to the target, if it is equal, we just return back k. K here is the index. In our case, I is 0, j is 6. So 0 plus 6 divided by 2 equals 3. 0, 1, 2, 3. So here is our pivot point. And we check if 7 equal to the target, which is 0 or not. If it is not, we have to move the I and j, and that is a tricky part. We also have to check if the pivot point here is bigger or equal to the I value, because we want to make sure that from the I value, from the I index until the pivot point, it is not rotated. Because if the k value here, if the pivot point here is smaller than the I, for example, if this is like 0, we know that this is not the range because our array is sorted in ascending order from the smallest to the largest. And this is 4, this is 0, so this is not the range. Let me put it back, 7 here. So if num mid or the pivot point here is bigger or equal to the num left or the num at the I index, if it is equal, we can do some check here. Else, we know that this is not the range, so we will have to check this portion instead. Let's deal with the first condition first. Here is the pivot point is bigger than the I value. We also want to check if the target is bigger or equal to the num left. We want to make sure that our target is at least equal to this number or bigger than this number, and it have to be smaller than the middle value or our pivot point, because we want to make sure that the target number is either equal or bigger than this one and smaller than the pivot point to make sure that it is in the range. If it is in the range, we can move the j pointer to be mid -1. So we can move j here to be here. We don't have to search for this part. We can simply search for this part because we already checked and see that it is inside this range. If it is not in the range, we can just move the I pointer to be the mid +1. We want to move the I here to be the mid +1, which is here. Else here, if this part is rotated, if the pivot point is smaller than this value, then we can start searching from this part first. And here we also want to check if the target is smaller or equal to the num right. So we want to check if our target is at least equal to this number or smaller to make sure that it is in the range at this part. And we also want to make sure that the target is bigger than the pivot point. So here, and target here is bigger than the pivot point, which is the num mid. And if it is in the range, we can just move the I pointer to be mid +1. Else, if it is not in this range, we do our search at this portion instead. So here, j equal to mid -1. Here in our example, our pivot point is 7, and 7 is not equal to the target number. So we check if the num mid here, the 7 here, is bigger than or equal to 4. And we check here if the target is bigger than the num left. Target here is 0. 0 is not bigger or equal to the num left. So we move the I pointer here to be mid +1. So our I here will be here. So we just remove half of the array effectively. We don't have to check at this portion anymore because our pointer here is between this element and this element now. I here is at the index 4 and j here is still at same index, and we calculate the middle index. 4 plus 6 is equal to 10. 10 divided by 2 is 5. So our middle index is 5. So this is our middle index. And we want to check if the pivot point here, the value at the middle index, is equal to the target. It is not equal to the target. So we check if the target 0 here is bigger or equal to the num left. So 0 here is equal to the num left here. And it is also smaller than the num mid. So we move our j pointer to be mid -1. So j here will be at this index, which is 4. And then we move to the next iteration. K, 4 plus 4 equal to 8. 8 divided by 2 equal 4 again. So our middle index is 4 at this element. And we want to check if the pivot point or the middle element is equal to the target. Of course, it is equal. So we just return back the index, which is 4. And that is our final answer. And if the target is not in this array, after our loop, we can return back -1. Let's code our solution. I will initialize the I index with the value 0 and j with num.length -1. And for our loop, we want to loop from the I index until smaller or equal to the j index. And then we want to get the middle index by mass.floor with I plus j divided by 2. Then we want to get the middle number, num mid equal to nums at the middle index, and also the num left. And the num right. This one should be I. And while looping, we want to check if the num mid is equal to the target. If it is equal, we return back the mid index. Otherwise, we want to check if the num mid is equal or bigger than the num left. If it is bigger or equal to the num left, we do another check. If target bigger or equal to the num left. and the target is smaller than the num mid. If it is, we move the j pointer to mid minus 1. Else, we move the I pointer to mid plus 1. Else, if the num mid here is not bigger or equal to the num left, we want to check if the target is smaller or equal to the num right. And also, the target have to be bigger than the num mid to be in the range. If it is, we move the I pointer to be at the mid plus 1. Else, we move the j pointer to be the mid minus 1. And after the loop, we return back -1 if the target is not in the range. I just realized I made a typo in the code. This one should be this one. Now, let's check the result. The time complexity for our implementation is O of log n. Because we never loop through the entire array, we always eliminate half of the array at a time. And the space is O of 1. Because in our implementation, we don't use any extra space at all. Hope you guys enjoyed it. See you next time.